Back to the urns and balls problem. Let's refresh ourselves quickly on what the problem is. We have 100 balls, 100 urns. Each time we put a ball in an urn. We do this until all the balls are exhausted, and every time, every urn has an equally likely chance of getting every ball. So now it's asking, what is the probability that exactly 2 balls are placed in the first urn and exactly 3 balls are placed in the second urn? So we have to have sequences with 2 ones, 3 twos, and 95, let's just call it no's, right? Because now we've divided it up. We have urn 1, we have urn 2, so this is 1 over 100, this is 1 over 100, and then over here we have everything else, and that's 98 over 100, right? So how many sequences are there with 2 ones and 3 twos? Well, number of sequences. So the number of sequences is just 100, choose 2, 3, 95. Right? And if you looked at the previous parts of the video, we're doing the exact same technique we did before to get this. We have 100 balls. 2 of them have to be 1s, so it could be 1, 1. 3 of them have to be 2s, maybe the last 2 or 3s. And then, the last 3 or 2s. And then everything else in the middle can be anything. So we just put these into groups. So the number is that. And the probability of each of these sequences, well, I have 1 over 100 contributed from this. 1 over 100 contributed from this. And same for these guys. So the probability here is 1 over 100 to the 5th times, and what's left over? 97 over, 98 over 100 to the 95th. All right. That one wasn't so bad. So this was E. Now how about F? What is the probability there are exactly 2 balls placed in the first urn given there are at least 2 balls placed in the first urn? So exactly 2 balls placed in the first urn given there are at least 2 balls placed in the first urn. So first we need to figure out what is the probability there are at least 2 balls placed in the first urn. So let A be the event at least 2 balls. At least 2 balls in urn 1. So we can think of this as if this is our sample space omega and all the possible things that can happen, we could get 0 balls in urn 1. We could get 1 ball in urn 1. Or we could get greater than or equal to 2. So this means that the probability of A, if we want to compute the probability of A, then we can just take 1 minus the probability that I got 0 or 1. So what is the probability of 0 balls? Of 0 balls? Well, that is just, now what would I have to get? I would have to get everything except urn 1 100 times. So that's 99 over 100 to the 100. What's the probability of 1 ball? Of 1 ball. The probability of 1 ball is I would have to get urn 1 once, so 1 over 100, and then I could get any other urn 99 times, so 99 over 100 to the 99. Then how many ways are there to do this? There are 100 ways of doing this because I have 100 choose 1. So this nicely cancels out. So we have 99 over 100 to the 99. So what are we left with now? So then the probability of A is 1 minus these two probabilities, right? Because I add them together, and that gives me the probability of A complement. 1 minus the probability of A complement. And what's the probability of A complement? Well, the probability of A complement is 99 over 100 to the 100 plus 99 over 100 to the 99. So this is 1 minus 99 over 100 to the, let's say, 99. And then 1 plus 99 over 100. All right, we're making progress here. This is the probability that we got 99, so that we got at least 2 balls in the first urn. And can we simplify this? Probably, but let's come back to that. Okay. Now let B be the event exactly 2 balls in urn 1. Exactly 2 balls. Well, we already know what the probability that we get exactly 2 balls in urn 1 is, because we did that in part 1 of the problem. And that's this right here. 100 choose 2, and then 1 over 100 squared, 99 over 100 to the 98th. So the probability that I get exactly 2 balls, well, then the probability of B is 100 choose 2, 1 over 100 squared, times 99 over 100 to the 98th. Now we just need to use Bayes' rule. So it says, what is the probability of exactly 2 balls given at least 2 balls? So the probability of B given A is equal to the probability of A given B times the probability of B divided by the probability of A. So, okay, we might look at this and say, I don't know the probability of A given B, but A is at least 2 balls, and B is exactly 2 balls. So, if I got exactly 2, I must have gotten at least 2. So this guy over here, this is 1. This is 1. This is 1. Because B is a subset of A. B is a subset of A. So if I know B happened, I know for sure that A happened. So this simplifies in this case. This guy goes away, it becomes 1. So now I have P of B divided by P of A. And isn't that nice? And I won't work out what the simplification is here. You can do some algebra and manipulate this, but that's not really the crux of the question here. So there you go. That is the urns and balls question. And as a side note, one other way to do E, you can do E in an alternative way if you look at the probability of A and B equals the probability of A given B times the probability of B. Right? You could use conditional probability again to solve this here, because you could say, well, exactly 2 balls in the first urn, that's B, and exactly 3 balls in the second urn could be A, and then use the fact that you computed this in the first problem, and then compute this. So I'm not going to show that in this video, but you should try it if you want more practice.